Hey everyone, good morning. Dijesh here from AWS User Group Kochi. Uh, this is the first Meetup in 2021. Unfortunately, we still don't have options for offline events. As soon as the places are reopened and the rules are taken out, we will definitely go back and schedule our offline meetups. Uh, 1 second. Let me share the agenda. Yes, here is the agenda for our today's meetup. We have one technical session. We have Vignesh from Innovature.ai. He will be delivering a talk on serverless data processing using Amazon ECS Fargate and Step functions. Vignesh is one of our active community member in AWSUGKOCHI, and he is one of our AWS community builder. And he has been practicing DevOps at Innovature Labs for last couple of years. We are happy to have you here, Vignesh. Welcome on board. And yeah, if the time permits, at the end of this section, we can have small Q&A with Vignesh. If you have any questions or suggestions, please post it in the YouTube comment box. We'll pass it to Vignesh. And if any of you are interested to delivering a talk with us, please do ping us in our social media accounts or just send a mail to info@awsugkochi.in. That's it from my side as an introduction. Let me hand over to Vignesh. Vignesh, over to you.
So the presentation. So hi, welcome everyone to the webinar on serverless data processing using Fargate and Step functions. So this is conducted by AWS User Group Kochi. So remember to join us if you have not joined us already. We have a meetup links and everything given by Dijesh. And we'll be having a lot more webinars and, if possible, in-person meetups in the future when the government and COVID permits. And also, I'm a part of AWS Community Builders. So AWS Community Builders is an international group of around 700 people currently. So it just started with the first batch. There was a beta batch, and now it's the main batch. So it's just started, and we get to see the main important part of this being the part of AWS Community Builders is that we get to see a lot of exclusive events and behind the scenes of AWS. Like if there are new technologies being released, we get a sneak peek behind those technologies before it's released to the public. So most of these are covered in NDA, so I cannot tell you anything, but still this is something that you get to learn. So that means you are a step ahead of the rest of the people who are part of the AWS community. I mean, that's a really good advantage to have. So if you like to know how to apply to join it, stay till the end. I'll provide you with a link where you can sign up and you can join the next team. I mean, the next batch of AWS community builders. And also I work at Innovature. So this was a project that I was a part of at Innovature, and all my knowledge comes from working there. So it's great. So if you're interested to join, do reach out. We have open vacancies and all. And so it'll be good to have you on board if you are interested in learning our tech and everything. So today's agenda regarding my presentation would be to give a basic introduction and to talk about what is serverless, and I'll talk about the requirements that we had from the customer, and I'll give you a brief introduction on the services that from AWS, the AWS services that we used for this project, and I'll talk about the actual infrastructure that was put in place to solve those requirements or to provide that solution for the customer. And finally, if time permits, we'll have a Q&A session where you can ask me doubts and I'll try my best to answer them. I don't know everything, but I'll try everything that I know. I mean, I'll share everything that I know. So who am I? So I'm a DevOps engineer. I have 2.5 years of experience working in the entire field. So I started in 2000, I believe 2.5 years ago, like 2018. And then it has been like this. So I started as a Linux admin, and now I'm handling Linux admin also, and AWS and Azure and a little bit of GCP. The GCP is Google Cloud Platform. And I'm from Thrissur, Kerala, and I have a background in electronics and communication engineering, and I do electronics, a little bit of embedded systems development as a hobby. So this, so how this talk came out is by DG's asking me if I would like to present a topic on any topic on LinkedIn, and that's how we started. So I know him from AWS UG Community Day 2019. It was like he was the one of the he had a main role in organizing that AWS Kochi Community Day event. So that's where I know him from. He is a really good person, and he's a like a proper techie. He knows things. He knows it really well. So that's about him. Like if you get a chance to meet him, do talk. He's a great person. And regarding the project, so the main idea about the project is that the customer had a lot of data that need to be processed at a single point. So these data comes from multiple AWS accounts. They have different environments in different AWS accounts. They have an entire organization architecture in their AWS account. I mean, their AWS organization, and there are different projects that are running that generates a lot of data. So this data should be processed in a single point, and then they need a processed output that they can download and use. So it was released very recently, and we had worked on it during Q4 2019, and then Q1 and Q2 in 2020. And this release was lagged a little bit because their rest of the environments had to be modified to work with this new project, this data processing project. So that's why there was it was released recently, and it's going really well. So what is serverless? So Shocker, it does contain servers. So without servers, you can't go serverless. But unless you're Parler, because if you're Parler, then you don't have a serverless platform. I mean, you don't have any platform at all. So if you don't know who Parler is, they are actually a social media network that was so much into uncensored media, but it was run by a lot of bad people, and they got shut down, and for the right reasons, actually. And so as this tweet says, serverless is serverless in the same way beef burger is vegetarian because you didn't personally see the cow being killed. So that's what kind of serverless means. So basically, like we have a lot of AWS services that are serverless. That's AWS Fargate, that's API Gateway, Lambda, Aurora Serverless. Then there is a lot of DB, managed DB services. And all those things are considered serverless because they don't have a management overhead. So what do I mean by management overhead? So if you provision an EC2 instance, you are supposed to take that EC2 instance, and then you are supposed to update the EC2 instance. You are supposed to check for the vulnerabilities in packages. You are supposed to update those packages. And you need to update the firewall, you need to update everything, every kind of single aspect of it, storage space, memory, instance size, everything has to be managed by you. So that kind of management overhead cannot be supported by most of the companies that we are starting up, because they won't have a dedicated resource for this kind of infrastructure management. So what that means is you slow down, your development slows down, your delivery to customers slows down, and that kind of affects your return on investment. I mean, when you slow down, or when your company slows down because of infrastructure issues, then you get less money. So what this does is, a serverless does is, it takes the entire management overhead to the cloud. That means the cloud provider is supposed to manage everything for you. So you get more time for development, you get faster delivery to your customer, and importantly, you are more secure because it's managed by the cloud provider. They know what they're doing, so they have the latest updates. They apply the latest updates. They provide the correct vulnerability fixes, and they do everything to make sure they also like they keep the firewall in check. So they do everything to keep it running smoothly. So you don't have to worry about that. From the cost side, there is a little bit of price increase when you try to go serverless, because as you know, it's managed by AWS, so they need to get that additional money from you. But compared to you yourself managing it with a dedicated resource, it's cheap, a lot cheap. And it also, when if you're provisioning a traditional servers, then you'll have to provision for the peak loads. So if you're in the morning, if your customer user base, if your number of users that's accessing your application is around 10, but at night it goes to 10,000, you have to provision for 10,000. So that's the problem with the provisioning as traditional server architecture. But with kind of serverless architecture, you have virtually infinite scalability. So that means if it's just 10 users, you just have to one instance of whatever a serverless instance that you have. Or if it's 1,000, it will automatically scale up to the requirement of 1,000. So that means you don't have to worry about scaling. You don't have to worry about the number of users accessing it. Everything is managed, automatically managed. I mean, when the number of users increases, the cost also increases, but then you will be getting more money from the number of users. So that kind of works out easily. So what are the requirements that we had from the customer? So first of all, this environment had to be permanent. Like it should not have much of a maintenance going on, because this is the core of their system. So being the core, they had to ensure that it's serverless, because they couldn't be bothered. I mean, it's really difficult to take down a server, then update it, especially if there's a kernel update. You have to reboot your system. I mean, AWS has a new feature to reboot live. The kernel's live, but other than that, like if you are managing it, you have to update the packages, you have to maybe restart the services. So this were not possible with this system. So the customer couldn't afford that. So they said they need serverless solutions because they cannot be bothered with the management. So we had to go use serverless. So that means no EC2 instances. And then next is it should be secure. So this data actually has a lot of user data. That means if this goes outside, it will be a really huge problem. So even if we use SSL or HTTPS, the customer did not want this data going outside the AWS network. So if you are using a API gateway, or if you are downloading a container image from ECR, that actually goes to the public internet. If you are using EC2 instance and downloading it from the ECR, actually the communication goes to the public internet, the public IP of the EC2 instance, and then goes to the ECR. So that is not something that the customer couldn't afford. So they had to keep entire data transfers, entire network inside the AWS network itself, without going outside into the public internet. And they said that they need to process at least 10 GB of data or more. So each single data had to be around 10 GB. That means if I had to use Lambda, that would have been difficult. In 2020, up to 10 GB temporary storage is there in Lambda, and you have EFS support. But back then, there was no support like that. Lambda only supported up to 512 MB of data in the temporary. So that means we couldn't use Lambda. Also, they needed quick processing, because these data, multiple accounts will be giving at different times. So that means they had to get this data quickly, like in 1 or 2 minutes. So just imagine this 10 GB of data should be processed in 1 or 2 minutes. So that's the kind of processing power that they needed. So that means Lambda is out of the question, because Lambda has a limitation on the CPU and the memory that it can use. And it should have. They also wanted it to have an API-based process starting and status checking. So that API should be publicly accessible. since it's just starting a process and it's just ending a process. So it's checking the status. They are okay with having public access, but it should be IP restricted. So that's a thing that they needed. And then there is file access restriction between the data sources. As I said, there are multiple data sources which are multiple AWS accounts, but they wanted it in such a way that even if they get the entire credentials of the other person, I mean the other AWS account, because this is an organization, a single organization. That means they, inside the organization, they might take this kind of credentials easily. So that even if the other person or the other team gets the entire access credentials of this account, they should not get access to the actual data. So that's something that they needed. And then they need to have S3 signed URLs for uploading and downloading files. And then, I mean, obviously they'll need that because everything is authenticated. And then they said they had an infrequent and non-uniform usage. That means they shouldn't, they sometimes they might send requests and they might ask for processing, but sometimes they won't. So that means they shouldn't be paying for the compute resources or any resources while the servers are not being, I mean, while the system is not being used. And finally, they needed authentication. So any kind of activity that happens inside this data processing project should be authenticated. So these are all the requirements that we were given for setting this entire project up. And so these are all the services. I mean, other than VPC and the security groups and everything like that, IAM roles and everything like that, these are the services that were used to make the entire system go serverless. So there was ECS Fargate, step functions, VPC endpoints, Lambda, API gateway, Cognito, and DynamoDB. So ECS Fargate is like, it's basically how AWS allowed the DevOps team to be lazy. So ECS Fargate is like, previously when you wanted to run a container in AWS, you had to first provision an EC2 instance and then download the container image to it and start running. And then there came Elastic Beanstalk with the Docker support, where you could have Docker containers running inside EC2 instances with Elastic Beanstalk managing them. And then there was ECS EC2. So ECS EC2 is where ECS servers uses backend EC2 instances that runs these provision containers. So you don't have to worry about updating or upgrading the latest package to the latest package. But still, I mean, like Elastic Beanstalk, but still you had to have a kind of, you had a visible EC2 instance running in the background to process it. But so that is kind of a security issue where you have SSH access into the EC2 machine. So that's not something that you don't want. So then they started with AWS Fargate. So it's a technology where the backend host is actually managed by AWS, and you only worry about the container that's running on top. So with the container, you can directly connect it to a load balancer. You can run them as batch process, as just tasks that start and exits at random intervals, maybe triggering with the Lambda or API gateway or anything like that. I mean, Lambda or CloudWatch events or anything like that. And then there is, that's there for ECS and EKS as well. So EKS is the Kubernetes counterpart for ECS. And ECS Fargate lets us do that. So it takes us our management overhead of using an EC2 container away from us, and just allows us to concentrate only on the application container, which we'll already be working on because that's our application container. And then there is step functions. So step function is like, I believe Coca-Cola uses it for their label printing or something, these step functions. So step function is basically how you orchestrate between the serverless applications that AWS provides. So if you have a Lambda and multiple Lambdas running for doing some tasks, and if you have a ECS Fargate or task that you need, if you have a web service using something, I mean, if you have a lot of microservices running like that, in that case, orchestration becomes difficult. Like if you have a condition checking, you should know like, okay, is this condition complete? And yeah, then move on to this condition. If no, then move on to this condition. So that kind of thing becomes difficult when you use call services directly. So if you're using a hotel booking feature, then you say, okay, let's book a hotel. So I mean, or plan a trip. So okay, hotel is booked, food is booked. Okay, fine. But then you cancel at the last moment. Then that means all these things should combine and say like, okay, hotel booking is cancelled and the food is cancelled. Or if you say, okay, I have special arrangement for hotel booking, then you don't need the hotel booking. You just need the food. So then you say, okay, I just need the food. So this kind of things could be programmed as a single separate Lambda instances, but then communication between them becomes difficult when these kind of logic is required between them. So if you need to add some additional features, what happens is that you need to change your entire application structure to add these additional features. So if you are also including a bus travel, so that means you have to first check this container, I mean this Lambda, and say that, okay, instead of calling the other hotel booking thing, first you should book the bus. And then you change that bus booking part, and then you say, okay, after booking bus, book the food. And then after food, you book the hotel. So that kind of change becomes difficult. So to prevent that, we use step functions where you can have this entire architecture orchestrated as a state machine. So state language. So what state language does is it gets first you say start with the task of Lambda, and then Lambda checks everything, it executes its function and returns if it's success or a failure. So if it's a success, then you do this. If it's a failure, then you do this. And you can also iterate over the outputs that it gives. So if it says, okay, you need food, food, bus, and hotel, then run all the 3 Lambdas and then book all the 3. Or if not, you just book, if it's just food and hotel, then just run those 2 Lambdas and then give the ticket. So that's how step functions allows us to work. So that means if you are adding additional server, you don't have to touch your code. You just have to add the new feature and then integrate into the step function, and it works flawlessly. So I talk about this step function board because it's a really good feature to have while running serverless applications with like this kind of a microservice platform. And then there's VPC endpoint. So as I said before, the customer had a requirement where all the network access should go inside AWS. So VPC endpoint and endpoint services allows us to do that. So what VPC endpoint is, it actually uses the AWS private link architecture and allows us to have from the VPC, we can access the public AWS APIs, but through the VPC itself. That means it does not go into the public web. So if you are running an EC2 instance, it will use the private IP instead of public IP to access the AWS resources. But this does come at a cost at around, its cost is taken per availability zone per number of VPC endpoints per hour. So that means if you have more number of VPC endpoints with more subnets attached to it with different availability zone and more hours it runs, the more you have to pay. But it's a really good feature to have if you are looking at an entirely secure kind of a network inside AWS. And then, as everyone knows, there is Lambda. So Lambda is a service where you can directly run code without having to provision a server or an environment or a virtual environment. Like if you're running Python, you don't have to run a virtual environment. You don't have to configure dependencies. So everything is done from Lambda side itself. So that's something that Lambda provides. And then there is the API gateway. So API gateway lets us have set up APIs, but without having to provision a server. So you just use API gateway, and then you say, okay, for this API, call this Lambda or this ECS task or whatever. And for this API, call this Lambda. And then the API gateway transfer all the information into the events or events of the Lambda, and the Lambda can process that event and give a response back. So that's how API gateway works. And then there is Cognito. So Cognito is like previously when we wanted a authentication system, you had to have Shibboleth or some kind of an authentication SSO system in place to make this work. So Cognito takes away all that difficulties and gives us a product where we can easily set up user pools, we can set up client pages for your application and everything like that. So when you log into Cognito, you get an access token, you get a refresh token, and based on the settings that you set in Cognito, you can have them expire at different moments. You can store the user data, like if you need email or phone numbers or whichever that information that you need, you can have that in setup. You can send the confirmation mails from Cognito using directly from Cognito or through SES. You can have set password difficulty levels at different points. So that's also something that you can do via Cognito. And so this kind of setup makes a management of the number of users that you have in your application a lot easier. And after Cognito, you have DynamoDB. So DynamoDB is a NoSQL database service. So it's not regional. I mean, it's kind of regional, but basically it has, you just provision the number of tables that you want. So if you need just a single table, you just make a single table, and then when you call the DynamoDB with that for that table ARN, and you can just directly access that DynamoDB and then get access to those files. It does come with a little bit of latency, but for a serverless application like this, where it's just a batch kind of process, it's not an issue. So that's about DynamoDB, and these are all the logos that these systems have. And so this is the actual infrastructure that we have in place. I know it looks complicated, but it's not. I mean, it's very simple when you get into it, but it works in a complicated way. But it'll be easier for you to understand once I explain. So this is the entire architecture. So we have so you just keep this in mind, because I'll be going into it deeper. So this is the architecture. Just keep it in mind. So first of all, on the left side, we had this entire set of data sources. So each of them are the AWS accounts that we have. So they access the API gateway in an IP restricted manner, and they access the API using Cognito authentication. So first they call the Cognito, they get authenticated, they get the access tokens, and then they communicate with the API gateway. And then once that communication is done, they get a signed S3 URL where they can upload their appropriate content, I mean their data, into the S3 buckets. So that's what happens in this section. And as you can see, each provider has a VPC endpoint for accessing the S3 bucket. So this is there because they need the data to remain inside AWS network. So even if they're uploading the data, they need it behind the AWS network. So they are using VPC endpoints at all the AWS accounts that they have, so that they can directly access S3 without going into the public internet. So S3 VPC endpoint, S3 and DynamoDB VPC endpoints are actually gateway endpoints. The rest of them are interface endpoints. So there is a slight difference. You can go through the documentation. It's not a huge difference, but it's there. I mean, the difference is mainly because VPC interface endpoints actually has a private IP address inside your VPC network, but VPC gateway endpoints just routes the public access through the AWS network. So that's how it works. So in VPC gateway endpoints, the public IP itself is used, but the public IP access does not go into the public internet. Instead, it goes through the AWS network directly into S3. I mean, to the S3 architecture and platform. So that's the difference between AWS VPC gateway endpoint and an interface endpoint. And also one more thing, this access is only allowed from specific VPC endpoint. As I said, each account has separate VPC endpoints. So we can actually use a condition where in the signed URL where we say, okay, this access or this user should only be allowed access from this VPC endpoint. So that's what we use here. And then there is this, this is our entire data processing architecture that we have. So once the data comes in, this is what works. So just keep this in mind, because we'll be moving on, I mean, to take a closer look into different aspects. So first, the customer calls the API gateway and they say, okay, we would like to start this data process. So for that, first they have to first authenticate using Cognito, and then they get the request token, and then they put the request token into the request to the API gateway, which authenticates which user it is, and then transfers all those data into the API Lambda. So this Lambda checks for all the data, checks which AWS account or which data source it is, and then updates that data into DynamoDB, and it as usual logs everything into logs, and also logs DynamoDB and the step function, all are connected through VPC endpoints. And once this data comes in, the API gateway checks for the user, which user it is, it updates it into DynamoDB and then comes back and then checks which role is assigned to this user. So this we need to do it because, as I said, the customer didn't want the data to be accessed by anyone else, even if they get the authorization or all the credentials that's in place. So that means each signed URL that's made by the Lambda is actually made by assuming a specific role, IAM role, that's created for that specific data source. So why did we do this? The reason we did is because if you create a signed URL to S3, you only have the ability to control the expiry, the time expiry at which, the expiry time at which the signed URL stops working. Other than that, you don't have any control over which permission that S3 signed URL has. So how do you control the permission? So, how do you give the permission? So the permission is obtained by the resource that creates that signed URL. So if you are running a Lambda and it has full permission to access your S3, and if you create a signed URL with that Lambda, that means the signed URL has the permission of that Lambda, which is basically you have permission to access the entire S3. So that's the kind of permission control that you have with signed URL. So in this case, we couldn't give the entire permission that Lambda has, because Lambda needs to check that it doesn't need access to S3. It doesn't check if the data is there or not. So that means we cannot give just random permission to Lambda and then create signed URL from it. So what we did is we gave the permission to Lambda to assume roles, and with that we created specific roles for each AWS account. And then once that roles were created, it was created with the CloudFormation template, so that we could have a specific template structure. We could have a specific ARN structure for that roles, so that we can actually easily code in Lambda. And once the role is created, Lambda actually checks for that role, for that data source, and then assumes that role, and then creates a signed URL. That means it has the permissions of that IAM role instead of getting the entire permission of the Lambda that we have. So this is what we did. So this way, even if so this IAM role has permission only to the specific path in S3 for that data source account, and it is conditional access, where we say that okay, this access should be given conditionally only if that access comes from a specific VPC endpoint of that AWS provider. That AWS account, so data source. So that's how this setup, we did this kind of a setup. And once that signed URL is created, it's given to the AWS account, that the application that asks for the signed URL, and then they upload the files. And once the file is uploaded, they say start the work. And when the start the work is given, API Lambda directly connects to the through the VPC endpoint, connects to the step function and start the step function process. So that's the step function process. And now we move on to, from the step function process, the first thing step function does is it parses the input and checks if there is any error. So step function does give an option for error handling. So if we can say that, like, if there is an error, if it's this kind of error, then do this task. If it's this kind of error, then do the other task. So like that, we have an option for error handling, or we can also retry also. if some kind of error if happens, that can be fixed by retrying the system, then that means we can set up retry rules to retry that option. So we gave that information to step function that, hey, these are all the things that they needed. There are sometimes a single request might have multiple separate data outputs that are required. So, and for that there will be multiple data inputs also. So they say, okay, there are 3 type of data inputs required, or there are 2 type of data inputs, data outputs required. So based on that, first it parses all the data that it gets as input, and if there is error, it directly connects to the there is a next slide is coming up, which is DB Lambda. So it directly connects to the DB Lambda, and then it says that, hey, this thing has failed. So then DB Lambda updates the DynamoDB saying that process, that process ID has failed. And once this step function starts, and if its inputs are correct, it just parses through. It's an array of different jobs. So it just parses through these jobs, and it checks how many jobs there are. So if there are multiple data processing jobs, then what it does is it creates a specific task for each job. This makes, even though this is costly, it makes the thing run faster, because they, as they said, they need this process done quickly. So we had to separate the number of tasks per each AWS task, so that we could have a faster processing instead of just waiting for each task to complete individually. So like that, it iterates over all the tasks that's inside that JSON array, and then starts an ECS task, and then passes all the data as an environment variable into the ECS task. So it just gives a process ID, and that's it. So rest of the data is ECS task updates from DynamoDB. And for ECS task to work, it needs to have an ECR. So ECR requires 2 VPC endpoints. It's the ECR API and ECR DKR. So I think it means Docker, but I think the DKR is used for container download, and ECR API is for authenticating and working with the ECR API. And once that's done, we have another bucket. There is data in bucket, there is data out bucket, and there is a template bucket. So this data processing is done using a data template that's obtained from the data template bucket, and all these access go through VPC endpoint. And for this also, we need to have that IAM role kind of access, because once the data is processed and it's finally complete, this data is uploaded into data out bucket. And once the data out bucket, the files are uploaded, the ECS task generates a signed URL with these IAM roles. The signed URLs are created with these IAM roles, just like the API lambdas, and then it updates those data into the DynamoDB. So this gives, we don't have to return back to the API lambda to create the signed URL again. So it's created here itself. And then, but we could do that with step function. We can do that if that's required. But here it's just a function, and then it does all these tasks. It processes the output and then puts it in a data output, and that's it. And then if this task is complete, it moves on to its next step. If it has failed, then it moves on to the next step, but it shows up in the step function as this process has failed. So that way we can know like if this process has failed or not. And currently it doesn't have an error handling, but that's in the next update. This process does not have an error handling inside step function. But even if it's failed, it's not a problem, because we can know it, and then we can restart the process. So, and all the logs that are created by AWS ECS Fargate is directly goes directly to CloudWatch logs, and from there we can access that logs. And once that entire process, data processing task is complete, it goes to the step function, goes to the next step, which is updating the DB. So this step is the same step that happens when the previous step has occurred. But the only difference is here the answer comes as success. So when it's success, it just checks the previous input, what it is. So ECS task has already given that input to step function, so that the step function gives that as input to the next stage. So that stage is DB Lambda. So in this case, the DB Lambda starts up, it checks for the input, understands what the input is. So it could be success, it could be failure, or it could be the input from the, if it's success, it checks the input from the step function. And once it checks the input, it says, okay, this kind of process ID is complete, and these are the details. So it just updates the DynamoDB with the required action that's required for that process. So it just updates it with the completed status for that process ID. And once that's done, the entire thing, the step function starts down, and it waits for the next other request. So in this entire thing, let me just come back. Yeah. So in this entire thing, this is the application that I talk. I mean, this is the actual total infrastructure, and as you can see, it's really simple, but it works in a complicated way. But I hope you understood everything, and that's about, yeah. So that's it. So thank you so much for listening to me. This is my Twitter. It's at Vignesh Giaret, and my email is iam@vigneshan.in. I have a website. I post blogs at regular intervals. That's vigneshan.in. And my company website is Innovature.ai. And don't forget to join AWS UG Kochi. We are a vibrant group. We are a lot of webinars like this will be coming up, and if time permits, there will be a lot of in-person events also. So you can go to our Meetup. That's meetup.com/AWS UG Kochi, and we have a Twitter page which is AWS UG Kochi. So do join us. And finally, as I promised, that's the link for AWS community builders joining. So if you are interested in building a community, if you are interested in joining, if you're passionate about AWS and working with technology, or not just AWS or any technology, and you would like to have a platform where you can express those things through blogs or running community events or setting up anything like that, do join us. So it's really great. You get to have a lot of people working, like you get to talk to a lot of people who are field experts. Like the entire community group is filled up with AWS people who work behind RDS, gaming technology, serverless technologies, and everything like that. So you just directly, you can just talk to those people and get answers from them if you have any questions or if you have any concerns or like that. So that's a really good thing to have. So it's just bit.ly/AWS-CB2021. You can just take a screenshot of this if you require. And so do join us. And that's it. Thank you so much for listening. It has been really great. And I thank Vignesh and AWS UG Kochi for this opportunity. I thank Innovature for giving me the time to do this in the time during my work. So thank you so much. Thank you, everyone.
Thank you, Vignesh. Yeah, thank you, Vignesh. We have a couple of questions. Let me pass it.
Okay.
With Lambda now supporting 50 minutes execution time, 10 GB memory, will you consider migrating to Lambda?
Yeah, the thing is like I'm even if it's not about the memory also, like there is an issue of storage space. So even if Lambda currently supports EFS, so that's an additional cost that we have to bear. And then the customer said that it could go about 10 GB of storage. So that means currently we cannot switch back to Lambda. And also mainly, as I said, we needed more flexibility into accessing the CPU, amount of CPU and memory that ECS has. So Lambda doesn't give us that kind of flexibility with the memory usage. So that's why we'll be sticking on to AWS ECS Fargate itself instead of switching back to Lambda. And as I said, this entire system was set up so that we don't have to change anything in the future. So that's what the customer also wants. So that's why we went with serverless. So just because we got a new feature in Lambda, it will be really difficult to switch it back to the Lambda, especially since the release is already over for the project.
Okay, thank you. We have one more question from Abhilash. Can you say something more about VPC endpoints and the use cases? And what's the difference between VPC endpoint and private link?
Okay, this is a good question. So VPC endpoints is a AWS service. So there are two kinds of endpoints that you can create. So one is VPC service endpoint and one is directly VPC endpoint. And VPC endpoints are of two types. There is gateway endpoint and interface endpoint. All these things comes inside the AWS private link architecture. So that's how it works. So it's the private link architecture. On top of that, there is a VPC service endpoint, and then on top of that, on service endpoint and the VPC endpoint things. And on top of VPC endpoints, there are gateway endpoints and infrastructure endpoints. The interface endpoints. So that's how it works. So VPC endpoints allows you to connect to AWS resources without going through the public internet. So if you are using ECR, so basically it allows you to connect to the AWS services without using an internet gateway. So you don't have to attach an internet gateway to a VPC. You can directly connect to the ECR or ECR API or Lambda or state function or anything like that. Not Lambda, but anything like that through the VPC endpoints instead of through the through the internal network of AWS through the data centers instead of going into the public network. So that's the advantage that VPC endpoints provide. And the use case that forced me to use it was because the customer said none of the data should go outside the AWS network at any point. Since these are very sensitive data, they are very sensitive and they can't afford to lose it, leak it or some way. So they had to make sure that the entire data stays within AWS network inside that protected this highly compliance with this highly compliance AWS network itself inside the data center. So that's why we used a VPC endpoint. And if you need information about service endpoint, so service endpoint is basically your way of creating a VPC endpoint as a service inside your network. So if you needed an application to be available to other accounts through the internal network of AWS, you create a VPC endpoint service. So that's how it works.
Yeah. Okay, next question from Onni Krishnan. Can we process only sequential tasks via step functions? Or branching or parallel tasks are possible?
Yeah, we can process sequential, branching, or parallel tasks with step function. You can understand that while you go through the state language that step function uses. So you can have iterations on a single input. You can have a single input given parallel to multiple tasks. That can be ECS task or Lambda or SNS or whatever that you need. And you can also have this running sequentially. You can have it branching. So it can check some conditions and then go do some other task. It can check other condition and go some other task and then get all the responses back. So like that, you can do whatever you want, that kind of orchestration that you want with step function. So there is no limitation on that.
Thank you. And thanks to Sujit and Vishnu for answering those questions in the comments as well.
Yeah.
Then, yeah, one more question from Abhilash. 1 second.
Okay.
You talked about multiple AWS accounts and organization structure in the initial part. Can you please say a bit more about it?
Okay, so AWS has a service called organizations. Currently, it's a much broader service is called AWS Control Tower. So I'll talk about Control Tower because that's a really good service to have. So consider you are working in a organization, really large organization with multiple projects and multiple people working, where you manage your AWS accounts. That means what you can do is you can create AWS Control Tower in a main AWS account that you have. So maybe your more senior, maybe your CTO or someone really senior has access to that account. And from there, you can provision individual AWS accounts based on your needs and give them permissions and have a centralized policy to manage them from the single topmost point. So you have SSO access, you have federated logins, you have single policy maintenance using AWS guardrail, and all those things you can manage with this AWS Control Tower setup. So all these are separate features, but you can have AWS Control Tower being the main point of contact for you to manage all these services. So in our case also, this customer has multiple projects and they have an organization architecture. So under the main organization, under the main AWS account, they have multiple organization accounts that they use for each project. So that's why that's what I told by organization structure. So if you go into control tower and start provisioning, it's available in Ireland, North Virginia, and some other regions. So it's not available in Mumbai if you are looking for it. Or yeah, so if you need to provision something, do check it out. It doesn't cost much. I think $5 a month or something. I mean that too for resources that are provisioned with AWS config and other small changes. But other than that, there is no cost for AWS control tower itself. So you can just go through it and you can understand how easily easy it is to manage the AWS organization and other accounts and your team using AWS organizations.
Thank you. And one more question from Krishnan. If time permits, can you please re-explain the authorization process in the solution?
Yeah, sure. For authorization, first this application inside this AWS account actually talks to the Cognito, and from Cognito they share their username and password. From there, they get a access key, a token which is access token, and then they get a refresh token. So access token is just for I believe it's we set it for 1 hour, and then there is a refresh token that we set it for I think 1 day or something. So if your access token expires, you can use the refresh token to generate another access token. You don't have to verify your username password again and again. And once that's obtained, you use that in API gateway. We have option to say, okay, this is the Lambda service that we need, but we also need to authorize using this service. So you can have a Lambda authorizer or a Cognito authorizer or an IAM authorizer also. So in this case, we actually use a Cognito authorizer, and that Cognito authorizer, what it does is, when it detects when inside the request, when it finds the API gateway directly gives that access token to the Cognito authorizer, and then Cognito checks if that's a valid access token. And if it's a valid access token, it responds to API gateway saying, hey, this is valid, so please do the next step, which is talking to the Lambda. So then it talks to the Lambda and then gives a response back to the application. If it's not a valid token, then it just returns a 401 or 403 error based on our setting up. So I hope you understand.
I think that's it. We don't have any other question. Thank you, Vignesh.
Yeah, thank you so much.
Thanks everyone.